this module is for the differential amplifier. So, if you all remember that we have seen the summation, right, or summing amplifier, where we can add the voltages and then we can amplify according to our amplification factor to get the final output. That means adding of the voltages, adding is summing of the voltages, that is why it is called summing, and then amplifier because it amplifies it. Same way, if we want to take the difference of the voltage, if we apply 2 voltages, we take difference of 2 voltages it, and then we have to amplify it, it is a differential amplifier. But before we go to the differential amplifier, a very important point that I kind of thought of letting you know, and most of you may know. So, this is a wire, right, this is a wire that we used for the for connecting to the breadboard. So, if I have a breadboard which is right in my hand, these are the wires that are used to connect it, right. So, this is a wire in my hand. How to take out this wire? So, we have to get this particular pin, right, you see here. On the black background it may be more visible, you see this pin, this one, and what I have is this one. So, what is a way of clipping out this, So, this is in my hand clipper, right, you can see, and I am placing this wire here, right, you can see, let me put it so that it is easier. You see I am placing it here, alright, in this particular area like this, and then I have to press it, alright. So, if I press it I get this, you see. So, I am not putting the wire in my mouth. I have seen lot of laboratories, right, people use this wire, they put in their mouth and they clip out the things. This is the wrong way of doing it, right. What I mean is, if you can focus on my mouth, I will show it to you, I will show it to you practically, so you understand this is the wrong way. You see what we do in most of the laboratories, right, we take this wire, we put in mouth, and this is how we take out the clip. This is wrong way, alright, this is wrong way of performing experiment, wrong way of understanding the things. This does not qualify you for good laboratory practices, right. So, do not do that what I did, I was just showing you because I have seen, and in fact when I was in my undergrad, right, I used to do it. So, it is from my own example, right, it is not bad if you have done some errors or if you have done something wrong to admit it, right. A brave person can only admit his mistakes or her mistakes. So, do not worry if you have done something wrong, the important is whether you learn from this errors that you made in your life, right. I learned that this is not the right way of taking out the wire way before, alright, not now, way before, and once or twice when I did it I found the why I have to use my teeth, it is wrong, right, there should be some equipment, right. Now, this is the one, there is another one which is automatic clipper, but anyway the point is, again once let me show it to you, we do not have to use your mouth guys, right. Teeth are very precious, our body parts are very precious, even we do not understand, it is very important. So, do not use teeth, do not use your hand, do not pull it like this, do not put in some, do not use knife to cut it, is wrong, use this, right, place the wire in this, you see very easy, I am placing it, right, and I am pulling off, I am just pulling off my wire, you see, ready, easy, alright. So, use this and then you insert this one into your breadboard is here right in front of me, I see it is very easy, when you do is perfect, 1 2 done, right. Again depends on how much you want, you open this, alright. There are lot of other effects that we are not learning in this particular course, which will cause when you take out when the wire is longer, when the wire is shorter, how much you are opening the contact area, lot of other things that comes into the circuit, which we are not covering in this particular course. However, it is very important that you follow the good laboratory practices. So, coming back to this particular module, here we will be looking at the differential amplifier. So, like I said, differential amplifier is nothing but it will difference the voltage and amplify it. So, the advantage is, if I have noise as the input signal, in the input signal, not as the input signal, if I have a noise, right, I am applying voltage V1, applying voltage V2, I have noise here and I have noise here, then the noise will also get difference. So, there is a difference of noise, right. The point is, let us see how we can quickly derive the formula of differential amplifier, and you have this on your screen. An op amp as a differential amplifier gives an output proportional to the difference between inputs applied at its non inverting and inverting terminals, amplified with a finite gain, alright. This is a definition. What? An op amp differential amplifier or op amp based differential amplifier gives an output proportional to the difference between the inverting and non inverting terminal, and it will amplify with a finite gain, So, let us come back here. So, you see this figure number 9, this is the differential amplifier, alright. What we have here? We have voltage V1, we have voltage V2, we have R2, R1, R2, alright. Easy circuit, very easy. Now, what will be the voltage VO at the output? I told you, if you remember, that it is always good to understand how you can derive the equation, but not really necessary that you remember the way of deriving it. If you remember the final equation, you can use this equation or formula for understanding your experimental circuits, alright. So, but if you want to just quickly see how we can derive this particular formula, we can see it, and it is very easy. Derivation is always very easy. See, now you see this V minus V plus, alright. These two things are there, V minus V plus, alright, this one and this one. So, V plus will be equals to V minus, right. Current into the op amp is 0, V plus equals to V minus. Now, I1, which I1? This one, you can see the arrow, this I1 equals to, what is that? V1 minus V minus upon R1 or divided by R1. What will be V2 or I1 which is here? I1 here will be V minus, right, minus VO divided by R2, very easy, right. So, we have formula for this, we have formula for this, right. Now, V plus is this one, V plus, alright. V plus is R2, right. See, here is a, what is this? Is a voltage divider, if you really see. So, what is that? R2 divided by R1 plus R2 into V2, So, that will be your V plus, right. Now, V1 minus V plus upon R1, V1, this one, just see this one, alright, V1, V2. So, if I want to have I1, then V1 minus V plus by R1, V plus minus VO by R2. How? Because I am considering I1 here and I1 here. So, I am substituting, not this one, forget about this, just consider this I1 and this I1. So, this I1, if I put the formula here, that will be V1 minus V plus upon R1 equals to V1 minus or V plus minus VO upon R2. Now, what is my V plus? My V plus is R2 upon R1 plus R2, right. Here V plus R2 upon R1 plus R2 into V2, alright. So, if I put this formula, I further solve it, I will have this particular equation, and further solving this equation, I will arrive to this particular equation. So, if you solve it, it becomes very easy to understand how we can derive to this particular equation. Now, if I do not consider anything, only I consider the final equation, what I see is that the final equation depends on R2 by R1. So, my R2 by R1 is my amplification factor, R2 by R1 is my amplification factor, and the difference of voltage V2 minus V1. So, this is the difference of voltage V2 minus V1. So, let us assume that V1 equals to 2 volts, V2 equals to 4 volts, and R2 by R1 equals to 10, alright. If this is given, what you will have? VO equals to 10 into 4 minus 2, 10 into 2, 20 volts. Would I get 20 volts at the output? I will not get 20 volts at the output. Why? Because my bias voltage is plus 15 minus 15, right. But what if I have V 2 equals to 3 volts? Then I have 3 minus 2, so that will be equals to 1, 10 into 1 equals to 10 volts. Would I get this? I will get this, right. So, very easy, if you remember the formula, you can solve the differential amplifier. Now, let us see that actually if you want to use the differential amplifier and you want to see whether it is working or not in terms of experiment, how to perform the experiment, all right, how to perform the experiment. So, we go to the next slide, and here you can see differential amplifier in terms of experiment. So, what is experiment and how we can calculate the gain of a differential amplifier. Here the idea is to understand what is the gain of the differential amplifier, all right. So, the first thing is you should connect the circuit as shown in figure. The circuit is similar, it is very easy. V1, V2, you have R1, R3, R4, R5, R6, it does not matter what you say here, it is finally R2 by R1 or R3 by R4, all right, R3 by R4. So, you do not get confused when you see R3, R4, R5, R6 and suddenly you have equation VO equals to R2 by R1, V2 minus V1. It is similar, it is nothing but R3 by R4, R3 by R4, all right. So, this is your feedback resistor. So, I can still write R3 by R4 into V2 minus V1, all right. So, if you cannot see, let me write it here. Here I write R3 by R4, right, into V2 minus V1, right. So, do not worry about if the formula says R2 by R1, all right. So, coming back to the circuit, we have to connect the circuit as shown in figure 10, which is this figure, right. Apply 1 volt peak to peak sine wave at 1 kilohertz to V1. So, we are here V1 we are applying 1 volts, right. Peak to peak, you know what is peak to peak, sine wave, peak to peak voltage, let me draw it correctly, 1 volts peak to peak, all right, 1 volts peak to peak. What is the frequency? Right, frequency 1 kilohertz, 1 kilohertz we apply, 1 volt we apply to V1, 2 volts we apply to V2, frequency is same 1 kilohertz. So, 1 volt here, 2 volts here, right, and then we have to observe the output V out and note down peak to peak value in the table below, all right. Try to see how to write the things correctly, all right. So, figure, if I use figure, if I say F capital here, I should have table T capital here, all right. So, try to be consistent, even you do not see consistency in my note, always understand that consistency is very important when you write, when you present, all right. So, table always when we write T should be capital, right, T should be in a uppercase. So, repeat the experiment for higher and lower amplitudes and note down the observation. So, let us see how to do this experiment on the breadboard, and we will note down the values, all right, for this particular differential amplifier. So, let me request Sitaram Gupta, right, you guys already know him, he will help us with this particular experiment which is the differential amplifier. Sitaram, can you please come here and show the differential amplifier to the audience, this particular one, yes, this one, you can see 4 resistors, right, one is RF or R2, one is R1, another is R2, another is R1. So, our formula if you remember is VO equals to R2 by R1, V1 minus or V2 minus V1. So, he has connected this 4 resistor with this operation amplifier and he has applied or he will apply plus 15 and minus 15 as a bias voltage to this amplifier, and then we will see what is the input, that is V1, and what is the input V2 and what is the output voltage correspondingly. We have to use here the DC power supply, we are to use function generator, and we can use oscilloscope or we can use multimeter, alright. So, let us see, can you please connect now plus 15 minus 15. So, you see the this is the right way of performing the experiments, the power supply is off, you see power supply is off, alright. Now, again understand that if you are careful it is okay, but generally always try to be more safe, right, and close your power supply, alright. So, plus minus 15 is connected, excellent. Now, he is applying the plus minus 15 to the operation amplifier as a bias voltage. Now, what is the second step? Second step, if you see the screen, it is written that now you apply 1 volt peak to peak sine wave at 1 kilohertz to V1. So, if you come back to the experiment board and you see the function generator which is on my right, this one, okay. What he has applied, if you can focus, 1 kilohertz, right, and he has to apply 1 volt peak to peak. So, you guys already know how to use function generator, or you have seen at least, right. So, you see what he is applying, he has already applied 1 kilohertz frequency and now he is applying 1 volt peak to peak. So, let us see 1 volt peak to peak, 1 volt peak to peak. You can see here in the amplitude it is already written 1 volt peak to peak, right, frequency 1 kilohertz. Now, this particular is one channel, second channel he will apply 2 volts peak to peak. So, we are just adjusting the function generator. Now, again 1 kilohertz is same, but we have to change the voltage, you have to press the amplitude button and then change your voltage. Here it is 2 volts peak to peak, right. Earlier it was 1 volt from one channel, second channel is 2 volts peak to peak. So, if you want to see both the channels you can see that as well. If but the point is that we have now connected 1 volt to one channel and second volt to second channel, alright. You can see here 1 volts applied to channel 1, 2 volts applied to channel 2, 1 kilohertz frequency for both the channel, phase is 0 degree, offset is 0 millivolt. Now, he will connect this voltages input signals to the differential amplifier. So, again you come back to the circuit once again for a second, yes. So, what he has done, he has 1 volts here, he has adjusted 2 volts here, and then he has to, this 1 volt and 2 volts is coming from the frequency generator, this 1 volt and 2 volt is coming from function 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 generator generator generator, function generator. You applied 1 volts and 2 volts the input signal of this differential amplifier. So, you have to connect V1, V2 and ground, right, with the function generator. So, when you always take a probe, always try to see whether probe is working or not. You have to connect the probe in a proper manner. So, you understand whether the voltage that you are applying makes sense or not. So, a lot of things you have to understand, do not just think that once you are applying 1 volts it is done. You have to check it with oscilloscope, you have to check it with your multimeter, see the probe whether they are properly set, and then you apply to the circuit, okay. So, now once you make sure that the probes are okay, then you can apply 1 volts to the as V1, 1 volt, that is channel 1 to V1, second 2 volts. So, another terminal will be ground, then we have to connect 2 volts. So, if you see and if you can focus on what he is doing, it is easier. We focus on what he is doing, yes. So, he is connecting the ground to ground and he is connecting the signal to signal, he is testing this thing on the oscilloscope. He is testing this thing on the oscilloscope, and now he can see that it is okay, whatever he has applied 2 volts it makes sense, and now he will apply this 2 volts which you can see he is connecting to the V2 and black one to ground, excellent. So, now we have applied V1 and V2 and there is a ground signal. Now, what we have to measure? We have to measure the output of the differential amplifier. So, he is connecting to the output of the differential amplifier, and if you see on the oscilloscope please. So, what we see, can you show Sitaram, where is the output? Output is this one, which is a signal and which is about 1 volts on about close to 1 volts peak to peak. That is that what voltage we have applied? We have applied 2 volts, right, at V2. We have applied 1 volts at V1. What we are getting? 2 minus 1, which is 1. Why? Because the gain here is 1. The gain that we have set here is 1. That means, if you come back to the circuit, what is R3? R3 is 1 kilo ohm. What is R4? R4 is 1 kilo ohm. That means, your gain would be R3 by R4, 1 by 1 equals to 1. Gain is 1, right. What is the input signal? Input signal is 2 volts, input signal is 1 volt, 2 minus 1, right. So, formula is here, So, I will write it down here once again. V out equals to gain is 1 into V 2 volts, V 1 1 volts, this is equals to 1 volt. That is what we see 1 volt on the oscilloscope. That is what we see 1 volt in the oscilloscope. So, if I want to write in the table, right, what I will write? 1 volt, 2 volts, V out is 1 volt, right. Differential gain, if I want to write, then it will be 1 divided by 1 or 2 minus 1, right, which is equals to 1. So, gain is 1, alright. Common mode gain, we will not worry about this right now. We will not worry about CMRR, because this experiment is not to understand common mode rejection ratio, this is an experiment to understand the differential amplifier, right. So, we will do a separate experiment where we will understand common mode rejection ratio. So, here my output is, or my gain is 1. So, it is easy to understand how you can measure the gain of a differential amplifier, it is very easy, right. Now, let us change the voltage. V out 1 divided by V 1 minus V 2. So, now V 1 and V 2. So, let us apply different V 1 and V 2. Just apply whatever you like. See, this is not something that we have already prepared, alright guys. You should understand this thing, that we have not prepared some experiments to show it to you. This is live. We are assuming any voltage, and to make you understand that you do not have to really prepare for experiment. Think 1 volts what will happen, 0.5 volts what will happen, 2 volts what will happen. So, this is how you should do the experiment. It is not something that you already have said, okay, it is when Sitaram I call you, you apply 1 volt, so when I call you apply 2 volts, no, right. I give him the freedom and he is applying voltage according to his understanding. Let us see what happens at the output, alright. So, that is even interesting, right. So, let us see. Okay. So, let us see what voltages he has applied as a input signal. Can you show both the channels please? So, if you see function generator, and if you can focus it, then you can see here he has applied 1 volts and 3 volts, channel 1 1 volts, channel 2 3 volts, right. We can see same thing, frequency is same. In this case, when you change the voltages 1 volt and 3 volt, what is the expected output? What is the expected output of the differential amplifier? Let us see theoretically. Theoretically, it should be 3 minus 1, right, which is 2 into what is the gain? Gain is 1. So, output should be 2 volts, correct. Now, let us see what is output. Let us see what is output. You can focus on the oscilloscope and you see 1.96, right, close to 2 volts. Again, why this is the case? Because we have resistors which may not be exactly 1 kilo ohm. See, this tolerance is making so much of effect, right. 1000 ohms and 950 ohms will change the gain, we cannot have same gain which is 1. So, always understand that the small change or small tolerances that you see in the resistance value will have a significant difference on your overall output. So, 1.96 and 2 volts has 0.4 volts difference, 0.04 volts difference, right. 0.04 volt difference for you, it may be like okay, it is 0.04, it is not okay, because when you are understanding the sensitivity of a sensor, this is a big difference, it is a big difference. So, you have to compensate your circuit, right, and that is why the selection of your resistors, accurate resistors is extremely important, all right. So, coming back to this one, which is our differential amplifier, what we see in another case, he applied 1 volt and 3 volt, output voltage that we observed was 1.96 volts, right, and if I calculate gain, then this is the practical gain would be 1.96 divided by 1.96 divided by 2, right. See, 3 minus 1 is 2. So, which is approximately close to 1. So, my gain is 1, in fact, we have already know theoretically it is 1, experimentally it will be close to 1, not 1, all right. So, this experiment shows how to calculate the gain of a differential amplifier, differential amplifier because it takes the difference of voltages, amplifier because we can change the gain of the voltage, that is difference of voltage, by changing the value of feedback resistor and the input resistor. Now, one thing you understand is that the R4, in this case R4, let me just clear this screen, it is easy to understand. Okay. R4, R5, R6, R3, they are same here, but if you want to change it, then it will have a different kind of function, all right. So, we are assuming that all the resistance are same, in this case it is like this, but this value and this value should be same, this value and this value should be same, all right. Then you can have the similar formula. So, if the value which I have crossed and value which I have double ticked, right, this should be same, all right, then in that case this formula is still valid, right. So, I hope that you understood the function of the differential amplifier, and let us see the another experiment and understand what are the instrumentation amplifier. This is a differential amplifier. So, let us see in another module what you mean by instrumentation amplifier and how it is different than the differential amplifier, all right. So, I hope that you understood the function of the differential amplifier and how it is useful and how you can change the signal from the function generator, how you can use the oscilloscope to look at it, what are the bias voltages, how you can use multimeter, how you can use probes, how you can use wire, right, how to take out the wire, right, how to take out the wire using the device that I have or the equipment that I have or the tool that I have, right. This is tool TOOL tool, this is equipment, right. Understand the difference, tool is different, equipment is different, device is different, systems is different, all right. So, do not confuse yourself, all right, and the best way of learning is learn in your own language. English is one medium through which we can communicate, but it is not a mandatory thing to understand only everything using English. If you know how to speak Kannada, you speak Kannada, you speak Tamil, Telugu, Hindi, Gujarati, Marathi, whatever language you speak, Punjabi, it is on you how you understand the concept, all right. So, do not worry if you do not really understand in terms of English, understand in your own language, it is always easier, all right. Do not just focus at, oh my god, I cannot speak in English, so or I cannot communicate in English in such a good way. What can I learn electronics? Yes, you can. Yes, you can, right. If you go to China people they learn English directly in their graduation or maybe not. So, till there they are learning everything, you can see lot of electronic items, right. They do not know electronics, they know electronics. You go to Germany, they speak German. So, it is not exactly that the only thing that you learn through a course is only through English. English is just a medium, because most of us here in India we try to understand or communicate in a language which is easier, and I feel that English is really easiest way to communicate, but not easiest ways to understand. Alright, to understand anything, your mother tongue is the best way to understand the things. So, keeping in mind, we will finish this lecture, and I hope that you have a good time ahead and you learn more things, and I keep on showing you new experiments which would be helpful for you to understand the concept of op amps and in general their applications and the integrated circuit, which is again our operation amplifier. Alright. So, I will catch you in the next module. Till then, you take care. Bye.